We're on the Dixie Fire. We're here to help monitor some plume dynamics and the generation of pyrocumulus clouds and understand kind of the fire weather conditions around this event. Well, these data will eventually be used to help our modeling effort. So we're running a high resolution, what we call a coupled fire atmosphere model right now. And we're doing that twice daily. And so it's run on a high performance computing system and it's very computationally intensive, but what it does is it actually forecasts the plume dynamics and how the fire is spreading and how the atmosphere is interacting with the fire and how the fire is creating its own weather. We need observational data to help that model validate it and keep it going. So like we'll take some of these data maybe tonight and then we can use that for the next simulation.
It's going to provide more situational awareness. It's going to help us with our plume observations, plume detections, and the winds inside our plumes. So this technology is going to help us with our firing operations. It's going to keep us safer and keep us from creating any more injuries or deaths on the line.
And did you get the angle of the bearing? So yeah, so none of these measurements are right. So we have to redo it. So we have to try to level this. So we might bring the truck. Yeah, so we have a Doppler radar, which is scanning the plume, and we also have a Doppler LiDAR in the other truck, which is actually doing a vertical profile of the atmosphere, and it allows us to understand how the winds are changing with height, and it also gives us a depth of the smoke layer. So we have two instruments running, and that way we can actually monitor the atmosphere from the surface all the way up.
The column, size of the column. This is also going to detect the winds in the column as well. So the winds in that plume and the direction of what it's doing might help us see if we're going to get any type of direction that's going to cause maybe one of those fire whirls or firenados.
I think, fire whirls are common on all fires. We see that all the time. Almost every fire has a fire whirl daily. But it's a larger scale vortex that can be classified as a tornado. Something like that's really dangerous. Not only does it damage houses, but it can travel much longer distances. The winds are much stronger, and it's actually bringing flaming part of the flame front into the circulation, so it's quite dangerous. There we go, shoot.
I think so. I could speak for CAL FIRE, and because they requested, I know this is going to help us in the future, and it's things like this that it's just going to help us in the future.